Hello everyone, welcome to the online lecture series on 8051 microcontroller. So in the previous lectures we had looked into different types of addressing mode and how and we have looked into some of the problems, that to the problems without using any loops. Okay, so from today onwards let us start with module 3 in today's lecture. So before moving on to the lectures, the actual lectures, let us look into the syllabus of module 3. So the whole module 3 has been divided into two types or two parts. Okay, in part 1 we'll be looking into the stack of 8051, and then how these stacks will be used in terms of subroutine programs, and then we'll be looking into IO port interfacing and then programming. So IO port interfacing in the sense in 8051 stack will be covering so what is stack and then how the operation of stack will happen in microcontroller, and then how these stacks will be used in terms of subroutine instructions, how we'll be using those call instructions in order to um, make a subroutine program. Okay, so in IO port interfacing we'll be looking into the port programming. So basically we are having totally 4 ports. Each port is of 8 bits. Okay, so how do we interface these ports in terms of how to make these ports as input ports, how to make these ports as output ports, and how we can interface these programs, that we'll be looking in terms of IO port interfacing. And finally we'll be looking up some of the programming examples, how can we write down the program for by making use of these stacks, and then how can we write down the programs making use of our ports, that we will be seeing in terms of some of the examples. Okay, so the part 2 is of a simple interfacing program. So here we are taking one problem definition, that is a simple switch and an LED to the IO port to switch on and off LED with respect to switch status. So this is the problem definition, switch and an LED. So how can we control the LED in terms of switch, and then how to write down the program for such particular thing. So that we will be looking in terms of interfacing programming, that is our part 2. Okay, so let us move on to, in today's lecture we shall look into 8051 stack. So basically we'll be looking in terms of 8051. Okay, so let us start with our syllabus. Okay, now let us move on. So before moving on to the actual programming, let us recap our what the organization of RAM in our 8051 microcontroller. So basically what we had said, our RAM is of 128 bytes, and these 128 bytes have been divided in terms of different registers, that each register is of 8-bit wide. Okay, so that is 1 byte, 8-bit, that is 1 byte. So by looking into the whole, if we are looking in terms of 128, so the register has been organized in such a way that these registers are divided in terms of, these are varying from 00 hexa to 7F hexa. Okay, so now these register banks, further this organization has been divided into different register banks, and then 16 byte bit addressable RAM, and then these from 30 to 7F hexa, this is meant for general purpose registers. So these are basically register banks. So each bank is of consists of 8 different registers. So you can observe over here, that is R0 to R7. So each register is of 8 bit, and in the similar way we are having register bank 1 and then register bank 2 and then register bank 3. So these register banks can be selected based on our program status word register, which is a special function register, by varying our rs0 and then rs1. And then we had seen in module 1 also how can we select these particular banks. So that is nothing but when rs0 and then rs1 both are 00, at that time register bank 0 will be selected. If it is 01, then register bank 1 will be selected. If it is 10, register bank 2 will be selected. If it is 11, then register bank 3 is going to be selected. By default, register bank 0 will be selected. And then here we are having a bit addressable RAM, which is varying from 20 to 2F hexa. Okay, so this area we cannot change anything, so since it is a bit addressable RAM. So and then from 30 to 7F hexa, this is again a user defined register, so where user can take use of these particular registers in order to manipulate the data. So this is all regarding the registers what we are having. So let us look into what is actually our 8051 stack. Okay, so let us look into, so what is section, what is stack is a section of RAM used by CPU to store the information temporarily. So as we can see in some of the programs, we will be moving our data in order to store that. Suppose in if you want to look in terms of port programming, so what we'll be doing, we'll be taking use of these registers which are present over here in order to make use of, in order to store the data temporarily. So see, if you want to store the data in terms of temporarily, so again what you will be doing, you will be making use of the move instruction in order to move the data, right? So if we don't want such type of things, then what we can do is we can make use of this particular stack, so where the data will be temporarily stored. Okay, so in order to have this thing, there should be a register where this stack is going to be accessed, right? So for that particular thing, we are having a register called stack pointer register. So this stack pointer register, usually it is gonna have what it is going to be having, so which it is going to have the address of a particular RAM, so where it is going to be accessed. Okay, so this register will be containing the address of the RAM. Okay, so when the 8051 is powered up, at that time the default address what is going to be stored in stack pointer register, that will be 07 hexa. Now when we look in terms of what, when we look in terms of our registers, our addresses are varying from where to where. Our addresses are varying from 0 hexa to what, 7F hexa, right? So here what we can observe is that our default value, that is default address which is going to be stored in stack pointer register is 07 hexa. Okay, so how can we perform this operation in terms of stack? So that is nothing but, so I'll be making use of two different instructions, that is push and then pop. If I want to put some data into this stack register or stack memory what we are having, so basically what we'll be using in order to dump the data or in order to put the data, so we'll be using push instruction. And then in order to take back the data, or if you want to pull back the data from the stack memory, then we'll be using instruction called pop. Okay, so let us look in terms of push and pop in later slides in a little more detail. Now here, as we have seen in terms of move instructions, we had seen that what we had seen, our we'll be writing our instructions in terms of what, move r2 comma r3. and then move R1 comma R2. So these type of instructions we had changed in order to access these particular register banks. As we have said, our default, it is going to be located where? Default, it is going to be pointing towards my 07 hexa over here, right? Now what we can observe is, whenever I call this push operation, at that time what is going to be happening is that the stack pointer register is going to be incremented by 1, and then at that particular address location the data is going to be dumped. Okay, so what is going to happen? First, it is going, this stack pointer what we are having, it is going to be incremented, then that incremented point address what we are having in stack point register, in that particular address location the data is going to be dumped. Now if I now by when I have powered on my 8051 microcontroller, the default address is which is going to be loaded is 07 hexa. Once if I call this push operation, at that time what is going to happen? It is going to increment to 08 hexa, and then in 08 hexa address location the data is going to be dumped. Okay, so now you can straight away tell that the first address location where the data is going to be dumped, that is going to be 08 hexa, and the address, default address location in stack point register is 07 hexa. Okay, now here what we can tell is that, again what we are having is that in between from 20 to 2f hexa we are having 16 bit addressable RAM. Okay, now here this particular data what we are having, this 16 byte addressable RAM what we are having, these are not accessible to the stack point register. So this particular memory what we are having, which is from starting from 20 to 2f hexa, this part of memory we cannot use it for our stack point memory, but whereas I can be using from 08 hexa, that is register bank 1, register bank 2, and then register bank 3 for my stack memory, and even I can use this general purpose the registers which are there, which are starting from 30 hexa to 7f hexa. Even these particular registers I can use as my stack point memory. Now what we can observe is that my stack point by default it is having what? It is having 07 hexa, that is my starting address will be 08 hexa. Now if you look at the uh, memory width or memory, how much memory I can have is, if we take this is 1f hexa, okay, and then the starting is 08 hexa, then the maximum height or the maximum memory what I can have is 18 bytes of memory. Okay, so if you take something like this, now if you don't want, if I want little more memory, because 18 bytes of memory is not at all sufficient for me. Suppose if there is a condition where this 18 bytes is not at all sufficient, then what I can do, I can make use of these 30 to 7f hexa. How can we make use of this 30 to 7f hexa is by loading our stack pointer with what? I'll be loading my stack pointer with the particular thing, like, so I'll be making use of what? I'll be making use of move. Okay, let me take it in a different way. So I'll be making use of this instruction, so that is move stack pointer, since this thing is sp, so I'll be move sp comma hash. So since this is 30 hexa, I'll be loading it with what? 30 hexa. Okay, so from this what I can do is that I can make use of this particular address location which is available for this thing, but by default I'll be making use of these particular address locations. Okay, so this is how the stack point operation is going to be done. So let us look into let us look into the further instructions, like how these can be accessed, how the push operation is going to take place, and then how pop operation is going to take place. So let me recap this particular stack point operation. So as we have said, default address location is what? Default address will be loaded with in stack point register is 08 hexa. The first address location where the data is going to be written is 08 hexa, and then here if you these the bit addressable registers which are present in from 20 hexa to 2f hexa, these are not accessible for what? These are not accessible for stack point memory. And then from 1f to from 08 to 1f hexa, total 18 bytes of memory what we are having, that can be used as stack memory. If we want if we want still more memory, then we can make use of what? We can make it use of this 30 hexa to 7f hexa. So by making use of 30 to 7f hexa, I should use my move instructions so that I can load this particular stack point register with this particular address by using immediate addressing mode. Okay, so let us look into the push operation. As we push data onto the stack, the stack pointer will be, that is SP, is going to be incremented by 1. Push the register onto the stack, we must use their RAM address location. Okay, now here what is the thing, I cannot write something like some instructions to be like what? Some instructions to be push R0 or push R1 or push accumulator. That is not at all accessible. Okay, if you want to push the data, or if you want to push the data into the stack memory, what we have to do is we should always write their address location. Okay, now if you look at let us take an example over here. Now we are having an example over here. Move R1 comma hash 24 hexa, move R2 comma hash 11 hexa, move R3 comma hash 0f2 hexa. Here what these instructions are going to do, these are the immediate addressing mode. That means I will be loading my R1 with 24 hexa value, and then my R2 with 11 hexa value, and my R3 with 0f2 hexa value. Okay, now here we are telling what? Push 1 we are telling. So push 1 in the sense I am pushing the contents of register R1, because by reset what will be happening? By reset, when you power on your device, register bank 0 will be selected. So when register bank 0 is being selected, then 0 the address of this particular R1 is what? It is 01 hexa. So here what I am telling, push 01 hexa. If I have called this particular instruction, so then what will happen is that the contents of this R1 will be loaded into the stack point memory. So by reset, what will be the case? By reset, our 07 hexa is our the stack point address. If I call this particular push operation, what will happen? First it is going to increment to 08 hexa, and then the data will be written in this particular address location. So now what will happen is that now when I call push, it is going to increment to 08 hexa, and the data is going to be written over here. Now if I call push 2, so again what will happen? So push 2 in the sense what? Push 2 in the sense this is the address location. Now if you write over here, now it is going to increment, and the contents of R2 has been written in 09 hexa. Now if I call again push, again what is going to happen? It is going to be incremented, and then the contents of that particular register is going to be written over here. Now one thing what we can observe is that over here you can observe is that now here what I have done is that first we have called push 1 2 3. Now if suppose if I this is the address location what we have taken. Suppose if I had taken something like this, push 2 and then push 1 and then push 3, so what would have happened is that in this first what I am telling, contents of register 2 you push into the stack memory we are telling. By default, where it will be pointing? It will be pointing over here. After that, it is going to increment. First push 2 operation we are telling. So the contents will be, that is 11 over here, and then 24 over here, because second time push what we are telling? We are telling to push the contents of register R1, and then here F2 hexa. So what is going to happen is that based on the addresses what you are giving over here, those particular address locations data is going to be pushed into the stack memory. Now here what we can say is that since it is 1, 2 and 3, so this is how pushing the contents is going to be happening. Okay, so now here what you can say is that this is one thing. Now if you want to push the data which is present in accumulator, simply by writing okay, so simply by writing, if I tell push, okay, if I write push A, so this is what, this is one way of writing. And then since we have said to use their RAM addresses, I can tell that push the address location of accumulator is what? It is E0. So I will be writing 0 E0 hexa. Okay, now if you look at this particular if you write this is totally wrong, and then this is always right. You cannot write with the register name or the register. We should always go with what? We should always go with what? We should always go with our address location of that particular register. Okay, so let us go back to our slide. So we should always go back to that. So this is how push operation is done. So let me recap this. So first, by reset it is going to be in 07. If I increment the contents of the address location what we have given, the contents of that particular address location will be returned into 08 hexa, and then 09 hexa, and then 08 hexa. Since we have called here to 3 different push operations, so 3 different push operations after the completion of this particular thing, this is the result what we are going to be there in our memory window, which is there in our RAM memory. Okay, so now let us look into, let us move on. Now let us look into the pop operation. So when we had done in that particular, in the previous example, where you might observe that we have done the push operation and our stack pointer was pointing towards 0A hexa. So maximum, if you look at this particular example, the maximum address location where the stack pointer has reached is 0A hexa. Now actually what we are doing our pop operation. If you look at the pop operation, what we have said, we had said that pop is the instruction where I can use. Again here also in pop operation, if you are doing if you are using pop instruction, again we have to go with the address location, RAM address location. Simply again here also we cannot use the naming conventions what we are using in our conventional way, like in terms of move operations. Here pop R2, pop R3, it is not at all acceptable. We have to go with what? We have to go with 04 hexa or 05 hexa with their address location. If you want to load something into the accumulator, again pop A, it is totally invalid. If you want to load if you want to pop out the data and put back into the accumulator, then what we'll be doing? We'll be using pop 0 E0 hexa, so that the contents will be loaded into the accumulator. Now here let us look into the operation of this. Now here we have written pop 4, pop 6 and then pop 5. There actually we had written 1, 2, 3, so that the contents of 1 and then 2 and then 3 have been loaded. Now if you look at the stack memory, this stack memory will be like what? It is last in first out. The data which we have put at the last, that will be taken out the first. Okay, So now here, as we have put in terms of 24, 11 and then F2, we will be taking out the data in terms of F2, 11 and then 24 hexa. Okay, now if you are taking in terms of F2, 11 and then 24, the destination will be what? The destination will be the address locations what you will be giving over here. Now here if here I am telling pop 04 hexa, that means the contents of 0A hexa will be loaded into 04 hexa. Pop 06 hexa, I am telling the contents of 09 hexa will be loaded into 06 hexa, and then pop 05 we are telling the contents of this will be loaded into this. So how the operation is going to happen? In the similar fashion, how the push operation was going to be done, first what we are going to do, we are going to increment our stack pointer register, and then we are going to put the data in that particular address location. Here what will happen, first it is going to take the data from that address location, and then it is going to decrement the stack pointer register. Okay, so now if you look at this, if I give first pop operation, the contents will be moved to that particular address location, and then you can observe the stack pointer register is pointing over here. Okay, now here 06 hexa we have said the contents of this will be loaded into 06 hexa. Now if I call pop, the contents have been loaded to here, and then when you call this 24 hexa, then again pop, then 24 hexa will be loaded over here. Okay, so this is how the stack operation is going to be done. As we have seen, this is just an animation like what we have done here. It is going to be disappearing and then it is going to be loaded over here, but actually it is not going to happen. Okay, so going on to the next slide. So what one might think that what is the upper limit of stack? So if you look at upper limit of stack, as we have said in the previous slide, the limit is what? The limit is 18 hexa, 18 bytes of RAM memory over here, and then 302 7F hexa of RAM memory over here. But when we, in order to use this particular general purpose registers which are available in RAM, I should load my stack pointer register with what? With the address location of this, that is I should write move sp comma hash 30 hexa. Okay, since this 20 and then 2f registers are not at all available. And there is one more thing, that is conflict with the register bank 1. Okay, since here our by default when we power on, the stack pointer register will be loaded with 07 hexa. The next the thing where actually the dumping of data happens is from 08 hexa. So 08 hexa, in the sense here this is register bank 0, and then here also register bank 2, and then here also register bank 3. So when I'm using, if I don't give stack pointer with 30 hexa, if I go on writing with just push operations, the data will be getting dumped where it will be getting dumped in these particular register banks. When the data is getting dumped over in these particular register banks, then I cannot use these particular registers which are available in register bank 1, 2 and then 3. So if you want, this is the conflict what is going to be happening in terms of what? In terms of the stack pointer over in 8051. So as a programmer, if you want to make, suppose if you are making use of these particular register banks, then what we need to do, we should always load our stack pointer with what? We should always load with hash 30 hexa, and then later on we should do our push operation. If we are not going to use these particular register banks, if we are going to use these particular register banks. So suppose if these register banks are not at all usable in my assembly level code, so then I can go with the default address location. Okay, so and one more thing is that if the memory required for my stack point memory, if it is 18, if it is more than 18 bytes of memory, then again I should go for what? I should go with the 30 hexa, like go by making use of the general purpose register RAMs, or the registers available in RAM. Okay, so let us look into the program in terms of Keel Microvision. So here is the piece of code what we have written. So I have moved some immediate values to register R1, R2 and then R3, and then we are performing push operation, and then again we are performing operation. So how this is going to be looking in terms of simulation, so let us look into it. Okay, now here you can observe what we are having over here. We are having 00 hexa over here. Okay, you can observe the memory window. Here we have made our memory in window to be 00 hexa. So here you can observe this is going to be bank 1, bank 0, this is going to be bank 1, and then bank 2, and then bank 3. So now let us look into this. Okay, let us execute, let us try to execute. So here move R1 comma 42, as you can observe over here our registers are totally 0, and then here you can observe the stack pointer, and then so here this is the stack pointer. Okay, so since we haven't started anything, it has been what? It's been 0 0. Now if I execute one, okay, first instruction, now you can observe the changes in stack pointer. Okay, now you can observe the stack pointer has been loaded with 07 hexa. Okay, now R1 also has been loaded with 42 value, and let me go with R2 has been loaded with 11 hexa, and then R3 has been loaded with 23 hexa. Okay, here also you can observe the same values have been loaded in terms of, if you want to look in terms of a memory window, here you can observe that thing. Okay, now if I call push operation, what is going to happen? The stack pointer is going to be incremented by 1, and then at that particular address location the data is going to be dumped, we had said. Okay, now you can observe this memory window over here, as well as this particular stack pointer after execution of this particular instruction. See, now stack pointer has been loaded with, it has been incremented to 08, and then at 08 hexa the contents of R1 has been loaded. Okay, so it has been dumped. Now if I press again, now you can observe 09, and then these contents have been pushed. Now if I call again push, now you can observe this 23 has been pushed over here. So the maximum address which has been reached is what? It is 0A hexa. Now if I pop out, so usually here what I'm telling, the last data which has been pushed is 23. Here pop 04 hexa I'm telling, so 23 will be loaded into where? It is going to be loaded into 04 hexa. Now you can observe the data memory after execution of this. See, you can observe the 23 has been loaded to what? It has been loaded, and the stack pointer has been decremented now. Okay, now again what we are going to do, again if I call push up pop operation, let me give this. Okay, now here we had given 06 hexa, that is why this particular 11 what we are having, this has been loaded into 06, and then the stack pointer has been decremented, and then again if I call pop, the contents of the 42 has been loaded into this particular 05 hexa. So this is all regarding how the stack pointer is going to be worked, and then so what and all are the uses of the stack pointer. Okay, so the stack pointer, here in basically in this particular lecture we have looked how, what is stack, what is stack pointer register, how the push operation is going to take place, how the pop operation is going to take place. Okay, so in the next lecture we shall look into how these stack operations are used, how the stack memory is going to be used, or how it is going to be useful whenever we are using, whenever we are going with what, whenever we are going with subroutine instructions, or like calling subroutine programs. So that we are going to see in next lecture. Okay. By this we will let us wind off this lecture 1. Thank you.